This video I'm going to continue on with providing examples of how to calculate capital budgeting metrics based on a financial forecast of a business opportunity. We've already calculated a payback period. This time we're going to start worrying about the net present value. And so obviously the first thing we would want from that would be operating cash flows, which we already have, so I don't need to get those again. I'm going to assume a cost of capital. So very similar to what we did up above with the free cash flows to equity and the equity valuation. But this is the weighted average. This is our assumed weighted average cost to capital, including both debt and equity. So usually that's a lower number, particularly when you consider the tax benefits. So when we put that in, generally we would expect it to be lower than the other. Again, we're just assuming it to be 10% right now. Other discussions about how to determine it. We're highlighting it in yellow because that's something that we can change. So then we're going to calculate discount factors for that. And we're going to use the same year information and so forth as before. So it's equal to 1 divided by 1 plus our discount rate, in this case cost of capital. Put the dollar sign in front of that. Raised to the power of the number of years. And remember, we're working with fractions of years when we're doing the first few months. And then we get to multiple years here. So there you go. You can see what that comes out to. And just for grins, if you wanted to change that to 15%, you could see that it would give you the same discount factor as for the equity. But we don't want 15, we want 10, so we'll put that in. And so now we want to do the present value of the operating cash flows. So that's another big difference here when we're doing NPV. We're using the operating cash flows, not the free cash flows to equity. So that is just simply the operating cash flow times the discount factor. Carry that all the way out. Then we have, again, keep saying this, the present, very similar to the free cash flows, present value of terminal value. But again, it's of the operating cash flows in this case. So that is equal to, let's just go get that terminal value first. So we need the operating cash flows, which are row 10 divided by our discount rate minus 2% for our inflation rate again. So there we go with that. And then we need to discount that back 10 years. So that's divided by 1 plus 10%. Raised to the 10th power, so that's discounted back 10 years. And we'll just go ahead and format that so that it's the same. See, that's a sizable number here. Much bigger, it looks like, than the other number, primarily for a couple of reasons. One is this is a bigger number. We just have, the operating cash flows are bigger than the free cash flows. We saw that before. But also, we're discounting that back at a significantly smaller rate, and so we're winding up with quite a bit more value there. And keep in mind that what we're getting here is the value of the entire project, not just the equity portion, so you would expect that the whole project would be worth more. So then the net present value is just equal to the sum of all of the present value of the cash flows plus the present value of the terminal value. So about 2.4 million. So Again, not terribly surprising. The overall project's worth about 2.4 million. The value to equity is about a little less than 1.4. The rest of that is basically value that's going to service the debt, pay interest, all those sorts of things. And so on an NPV basis, that's what you're looking at. Pretty straightforward. Again, the sort of theory behind why we do what we do and how you interpret that, that's a separate discussion. This is just really the example. Thanks.